intelligence.
Okay. Thank you, sir.
You can start your session right now from 11 to 11:45. You can continue, sir.
Okay, okay, sir. Thank you, sir,
Okay.
for a warm
Okay.
welcome.
Thank you. You can. Yes, sir. You can start, sir.
At first, I would like to say good morning to you all. Myself,
Yes, sir. Good morning, sir.
myself, Prithvishan. I'm working as a senior technical instructor in Aspire Vision. Sir, could you mute your audio? Because there is a lot of noise and it will create a problem in recording the video actually.
Okay. Okay.
Okay, so myself Prithvishan, I'm working as a senior technical instructor in Aspire Vision Private Limited. Today I'm here to present a talk on artificial intelligence. At first, I would like to put some light on the meaning of artificial intelligence, I mean informally. In computer science, AI is sometimes referred to as machine intelligence. It can also be said that the intelligence of the dumb machine in contrast to the human intelligence. So, at first, let us see what are the goals of AI, whether it can be interpreted as the traditional problems of AI, which includes reasoning, perception, knowledge representation, natural language processing, etc. Those are the primary goals actually. So let's come to the definition of AI. Uh, as it is, the definition has been put forward by Andrew Ng by Coursera. He's an instructor in the Harvard University. So he said that the rise of AI has been fully driven by only one tool known as machine learning. The most commonly used type of machine learning is supervised learning, right? We know that. So here we can say that, let's say we have an input A and the output is B. So there must be a mapping from input A to B, right? So this is what we call supervised learning. Let's see more elaborately with an example. Say we have an email, we have lots of email and we want to filter it out whether those emails are spam or not. So AI's job is to see whether those emails are spam or not, and the corresponding application is spam filtering. So here is like we have we have emails, and suppose these are the emails, and we have put it into a classifier, and it will classify into whether those emails are of primary type or these are of spam type. Okay, so moving forward, if we say we have an input audio and the AI's job is to test, transcript those audios, and the corresponding application is speech recognition application. So I'll show you some of my projects that I had made during my course, during this course of time. Number one project is Lucy, a personal assistant, which is basically a IoT device. Sir, can you keep your audio mute? Yeah. So I'll make sure that I'll show you this IoT in AI with IoT, and also a self-driving car that I had simulated. I had made a small code for that. I'm basically working on that. So let's continue. Suppose we have image radar info and as an input, and the position of the car are determined by the AI application, then the application is known as self-driving car. So now the supervised learning has been around for many decades, but it has really taken off like in the last few years. So you can see, let's see a performance versus amount of data that is generated per second. So the amount of data that we had really grown in the past few decades, and the data size has expanded into some petabyte or like terabytes or like every million every seconds actually. So thanks to the rise of internet and the computers basically. So you can see that the amount of data, say for example, the speech recognition data can be fed, and the amount we have in speech recognition, we have audio and test transcript as the amount of data. So if we see according to the traditional AI, if we use traditional AI, then we see that it doesn't show much accuracy, because it uses, although the amount of data is more, it should show the performance should be good enough, but it doesn't show anything like that. So we have seen in modern AI using neural network and deep learning that the performance is increased a lot with less number of data. So you can see the graph, the blue graph represents, the blue curve represents the modern AI with neural networks and deep learning, and the orange one represents the traditional AI. It becomes saturated at a point of time with the like amount of data over and performance. The performance becomes saturated. So AI has taken off recently because of the rise of deep learning and like neural network, and you can see that let's say an example what AI can do and cannot do. Say for example, we have something AI can predict like do well is just take a picture of the like images of the cars in front of it by using camera, or you can sense the environment using radar or like lidar, etc. Suppose the A is the like picture that it has taken from the environment, and after that it has detected whether that is a car or a truck or something else, and B is the corresponding output, that what is the distance, what is the position of the like the next car in front of it. Okay, so moving forward, what AI cannot do well, it cannot, suppose a construction worker holding his hand asking the car to stop is basically a gesture, right? So or someone over there is trying to wave a car or a bicyclist on the left hand to indicate that she wants to turn left, such that so if you see that people are making many gestures over there, but it is not possible for a machine to recognize all those gestures, human gestures, and build a machine. It will become much more complicated for humans, for the machine to recognize those gestures actually. So if we have say 10,000 samples of gestures, then it is quite possible to recognize the system. The system can recognize the whether to stop or not, whether there is a danger in front of it, what to do. The machine can understand. But if there are not that inadequate amount of data, then I don't think so machine can understand like humans. So these are called dumb machines. Like so it cannot compete with the human intelligence, right? So another example is the X-ray diagnosis. Let's say we have samples of 10,000 chest X-rays which can diagnose pneumonia, but the suppose we have say uh, something AI can do is it can diagnose 10,000 leveled images that the patient suffered from pneumonia. Suppose 10,000 leveled images are input to the system, and the output is the whether the patient is having pneumonia or not. Suppose something that AI cannot do is diagnose pneumonia from 10 images of a medical textbook, because medical textbook, humans can read the medical textbook, it can analyze the like text and images, and also it can say whether the person is having pneumonia or not, but the machine cannot do, as it is dumb. So let's see some strengths and weaknesses of machine learning. Machine learning tend to work well when suppose you are trying to learn some concepts, simple concepts, uh, such that something that you could do less than a minute of your mental thought, or less than a second of your mental thought. And secondly, if we have lot of data available, huge data sets, then machine learning, the performance of the machine should increase, because that there is lot of information available and the machine can predict it well. Suppose the machine, and also we have this, the machine tends to work poorly. The machine learning algorithms work poorly when it has like you are trying to learn a complex concept from a small amount of data. Or second underappreciated like weakness of AI is that it tends to perform poorly when the machine perform on new type of data that is different from the data it had seen before. Let me show you some examples such that you can understand it well. Suppose we have built a supervised learning system such that it uses A to B mapping. This is a pretty high quality chest X-ray. It is given over here, like these X-rays are like pretty high quality. Wait a second. Yeah, these X-rays are pretty high quality. Suppose we apply this AI system, the AI system that can differentiate whether the patient is having pneumonia or not from this high quality X-ray images. But suppose we apply this machine learning systems at different hospital or a different medical center, uh, where maybe the X-ray technician somehow have changed the pattern or the patient's orientation by an angle, or sometimes there is a defect in the X-ray, like scratches, or like some defect in the images. So the performance can be quite poor. In this is a defective X-ray of a pneumonia patient. The machine cannot predict well whether the person is having pneumonia or not. So from this we can say that today's AI is much weaker than human intelligence, right? So the term deep learning and neural network are almost used interchangeably in artificial intelligence, and even more, though they are great for machine learning, but there are hype and mystic about them. So let's demystify it. So let's say we have a demand prediction. Let's say we are building a t-shirt selling website, and we want to know how we price the t-shirt and how many units we expect to sell actually. So we might create a data set like this, where the higher the price of the t-shirt, lower the demand. So we can put a straight line that goes up like this, that goes like that. because we can see in the straight line we can figure it out that the price, with the increase in price, the demand falls. So demand can never go beyond zero. So the curve will flatten and it will be like that. So let's analyze this using neural network. Let's say we have A and B are, A is the input price and B is the output demand. So if we use something like a circle in between this A and B, this is nothing but a neuron. All it does, it computes the blue line that is drawn over here. Like this blue line, it computes and says that for what price, what is the demand. Let's see some more complicated example. Let's say in the last example, we have seen the price versus demand as the their performance issues. Basically, the demand falls with the increase in the price. Let's see if we have this price, shipping cost, marketing, and material. So for that, if we see that for the affordability of the customer or consumer, it can be seen that the price and shipping cost put in as an input in a single neuron gives the affordability, whereas the marketing will give us the basically we mark the companies of brand market uh, uh, shows their marketing policy just because they want to make aware of the fact that their product is out, and basically would the people will like to buy those products or not. So let's say marketing as input to a neuron produces awareness. So let's say we want to also see the quality of the perceived quality of the material, such that the price, marketing, and material to all together input in a neuron results in the perceived quality. So all these three, affordability, awareness, and perceived quality, put together in a single neuron to find out its demand. So here also we have this section. This section is considered as A as the input, and the output is, you can say, this section B as the output. Let's say we have let's see the deep learning part of the neural network, like a deep learning part of the AI, and like using the deep learning, we can ensure that if we use neural network along with the deep learning, we can find a good face recognition system. So let's say we have a face, we have a picture. The human eye can perceive the object very well, but the machine cannot perceive it well. It actually sees some values or some grid of like numerical values. So let's take a cross section of the cross section area of the whole image, and let's see the image will contain some values in terms of some pixels. So let's see, the computer sees a grid of pixels that is bright of the bright intensity values that tells for each pixels in the image how bright is the image. If it were a black and white image or a grayscale image, it will contain a single value. Now, if it contains three values, I mean, if the image is colored, then the each and every pixel will represent 3 values, that is red, blue and green values of the pixel intensities. Now in the last tutorial we have seen last like example we have seen this as price, shipping cost and marketing material, all those are like input to a neuron. Now say all those are basically numbers. So let's say we input these numbers as like input to the neural network like this, and we process these pixel intensities and find out whether whose face is this or who is this, like the image represents to which object or whatever it is. So we can see, suppose we have 1000 by 1000 like pixel values, like the resolution of the image is 1000 by 1000, so there will be 1 million pixels basically. So 1 million pixels, if it is this black and white or grayscale image, then 1 million will be single 1 million values will be there. If the pixel intensity, if it is a colored image, then it will contain 3 millions of like those pixels. Suppose in the first part of the input neuron, it produces some, like it detects some edges, say, sorry, yeah. So it detects some edges. Then the second part, it creates some objects like whether this is eye or nose or cheek or whatever it is. In the third phase, it will detect some of the, like it will create faces. All these things put together will detect whether the person is who, suppose I am having my face recognition algorithm, so whether I am Prithvish or not, it will be detected by the like machine. It is not our concern what after we input the like values in the neural network, it is not our concern to see what is going on inside. We are concerned only with the output of the total thing. So yeah, so let's see some trending topics of AI of 2020. First of all, AI has like I have seen a few days ago, like Intel has developed some modern applications or a hardware which is enabled with deep learning concepts, which can like visualize those images, and it can easily detect whether those images are of some like whether these images are something like whether this is a cat or dog or whatever it is. It can recognize of its own. The hardware, the chip itself embeds some of the softwares along artificial intelligence softwares. So artificial intelligence enabled software, extra hardware is needed basically. Suppose if you are trying to do some computer vision task on like our conventional laptop or PC, it will create problem if we are like working with more complicated or complex mathematical computation. So AI enabled chips will make sure that the task requiring face recognition, like then natural language processing, computer vision, etc., is much faster. That will make sure that. So here are some examples like NVIDIA, Qualcomm.
Prithvi sir, can you hear me?
Yes, sir.
Prithvi sir, hello.
Yeah, I can hear you.
Sorry to interrupt you. Actually, few faculty members or students would like to join. Can you allow them to join?
Yeah, sure.
Okay, please allow them to join for a few minutes because they are getting blocked. Now they can join, right, sir?
Yeah, I allow.
Yeah. Now you can continue, sir.
Yeah. So
Thank you.
Well, so next point is that
ম্যাডাম এটার উপরে
there
আমি
are,
একটা ছবি নিয়ে দিয়ে আমার একটা দিয়ে আর এটার উপরে আমার একটা রিপোর্ট দিয়ে নাম রেকর্ড করে আমি এ যা খুঁজে যে দরকার নেই সিমিলার টাইপের একটা নেট থেকে ডাউনলোড করে একটা রিপোর্ট দিচ্ছি ঠিক আছে আমি দেড় জানুয়ারি সকালে ডাকছিলাম মেইলও করছিলাম কাউকে আইসা নাই বলে ইচ্ছা নাই ঠিক আছে স্যার এই জন্য আমি
yeah. So there are billions of IoT devices in the world. So it is not possible for us to collect those data and process it. There are huge amount of data generating every per second of time, as I said before also. So IoT devices creates a lot of data. I will show you one of my IoT devices that I have made a few years ago. So the device IoT devices, so these data are need to be like, wait a second. Yeah, these data are to be processed or mined beforehand. So AI's task is to process those data. So now we can see that wait a second. Yeah. So example is weather forecasting device, solar panel, dustbin, etc. So now we have automated machine learning. As I have discussed earlier, traditional machine learning performs poor over huge data set. So AI's role is to enhance the performance. Now, if we say we have cloud computing and like artificial intelligence together, AI can be used to manage and monitor the issues in the cloud. So some experts predict that like AI can be used to automate the basic overflow or those the problems in the issues regarding the cloud, whatever it is. So the AI can manage that using both public and private cloud. So next point is we have artificial intelligence in cybersecurity. One of my friend from University College of London, he was working on some project with artificial intelligence, cybersecurity, and in IoT basically. So he said that basically the issue is that we have to handle, if we are using internet, we have to handle